Hey everyone, I'm Will Button, and I'm here tonight with Donn Felker. So Donn is he's a best-selling author. He's the founder of Caster.io. He's an Android GDE, fitness enthusiast, stoic, and a longtime friend. We've been talking about some DevOps stuff, and we decided to turn this into a live stream. Did I miss anything, Donn?
No, I think that's about it. I mean, we
Okay.
had just been kind of chatting offline regarding some technologies that pop up in like day-to-day conversations from clients or just things we've seen floating around on, various mediums. And you were about to start answering some of the questions, and then we kind of just decided maybe it'd be good if you did this on your channel and kind of went live with it.
Yeah, so here we are. So really, you were asking a lot about some different tools that you've heard about. You've heard about Cloudformation and Ansible and Puppet and Chef and
Hmm.
Terraform, and really just wanting to understand like what all of those are. Do the same thing? And I think
Yeah.
specifically for you, you were like, should I be using any of them, or which one should I be using? Right?
Yeah, a lot of, I mean, for years I've heard about, Puppet or Chef or all these different technologies that seem, and again, I'm glad that we didn't have this conversation offline because I'm coming at this from kind of a newbie standpoint because I'm not a DevOps person. And so like I see Puppet and I've heard about it, and I hear Chef and I've heard about it, and I heard Ansible, and they all kind of to me start sounding like some way to perform like some type of server automation. Is it just firing up a server? Is it commissioning servers? Is it I really don't know what it's for, why I would use one over the other. To me, I feel like they all do the same thing. I'm sure they're there for a different reason. And then at the end, I'm kind of I'm in the camp now that's been using a lot of Docker Compose for local development. I kind of wonder, I'm like, all right, well, how does that, or does it even compare to Docker? Is that something completely different? So I kind of wanted to open it up, maybe like, what is the difference between, Puppet and Chef, and why would I want to use them or something?
Yeah, right on. I think you're right on it because I know a little bit about how your business is architected and using
Hmm.
Docker and SaaS platforms like Heroku. It's hard to see where these tools would fit in for you.
Yeah.
So, like I think if we step way back, like a lot of these tools were created before Docker had even a foothold in the way that we run applications. Um, but so if we start like at the outermost perimeter and work our way in, I think that will help. And so if we
Yeah.
start in that outermost place, I think Chef belongs there. And Chef, it's kind of changed its what it does well over the last few years because right now it's really good at building like this compliance framework, for
Okay.
your data center. And I think a lot of these tools make a lot more sense when you're talking about having your own physical servers, and they all have plugins or natively work with cloud-based providers like AWS or Google or Azure. But they all got started based on managing hardware in a data center. And so Chef's strong point is really about managing compliance of your entire network. So it's not necessarily about how things are configured. It doesn't really care how they're configured. It's just that if you say it should be this way, then it runs background processes to make sure that it is that way. And it focuses a lot on the network and infrastructure stuff. Um, Terraform kind of plays into that role as well, not so much in the compliance aspect of it, but just as far as like building out the infrastructure. Terraform's really good at building out, if you look at it from an AWS perspective, building out the VPC and setting up your subnets and defining the network environment and launching some of the EC2 instances. But both of those stop short of actually configuring the EC2 servers themselves.
So,
And
okay, so they don't, so Chef and Terraform don't actually configure or set up the servers.
right, right.
So
Terraform,
what?
you can make it do that, but it's not one of those things that really does well.
I guess so. So as you said, that Chef was a compliance framework, and then Terraform does something similar to that. I'm trying to wrap my head around that a little bit. If you could kind of retouch on that again.
Yeah, so Chef is more about monitoring the way that the environment's built. Terraform's a tool for actually building that infrastructure itself.
So if it doesn't build the servers out, what do you mean by build the infrastructure out? Maybe I'm confusing the two.
So the infrastructure meaning your VPC and AWS, your network, your subnets, your S3 buckets even.
Okay, so the actual, almost like you said, almost like the physical, I guess you would say, I guess you're looking at what's the 7 layers? It would be
the
one of those.
7-layer network model. So layer 7 is the physical layer.
Yeah. So it's basically you're setting up, the network. You could be setting up the subnets. You could be setting up anything like that. That could be, your virtual private network on AWS if you're going to have one. It's kind of configuring all that. Is that correct?
Yep, that's right.
Okay.
That's right.
Okay. And that's what Chef and Terraform do then, right?
Right, yeah.
Okay. Now, what does the compliance part of Chef do, though? What is that? Why would someone use that?
So that's for, it's been several years since I've used Chef, but it's mainly, as I remember it, it's for like highly regulated industries, like finance or healthcare, where they have to have tight control and tight restrictions on exactly how things are configured and actively monitor to make sure that it maintains that configuration.
Oh, okay. All right. That makes sense then.
Yeah.
And then, so that's Chef and then Terraform. And then do any of the other ones relate to that as well, such as, Ansible or Cloudformation or anything like that? Or are those completely different buckets or what do they do?
So they're completely different. Cloudformation kind of overlaps with all of the ones that we're going to talk about, but it's AWS specific. It's AWS's tool for doing all of these things. So when you talk about Chef,
maybe we should leave that one for the end or something like that.
Yeah, we'll come back to that one because whenever you talk about Chef and Terraform, Ansible and Puppet, and SaltStack too, we can't forget that one. They work with pretty much any provider, but CloudFormation is specific to AWS only.
Okay, all right. So that leaves us with what? Puppet, Ansible,
so we've got
and then
Puppet,
SaltStack?
Ansible, and SaltStack, that's right. And I've never actually used SaltStack, so I don't know a lot about it, but I have used Puppet and Ansible quite a bit. Both of those are what we call configuration management tools.
Okay.
So they're whenever you think about configuring and building a server, if you go way back to pre-DevOps days, whenever you would get a new server, you would sit there at the keyboard in the data center, with your 3 layers of jackets on and like actually type in the keyboard, and load floppy disk or CD into the server to bring the server online and configure it. And so that's what these tools do. They're made to bootstrap a server from the ground up, and if it's going to be an Apache web server, it'll install Apache, and then it'll load the configuration that you want on there, and just take care of all of that so that you're not doing that manually. The benefit to that is by using one of these tools, you can do that across hundreds of servers in an automated fashion rather than having to log into each of them individually.
And so are these basically just competing products, really, between Puppet, Ansible, and SaltStack?
Yeah. And you gravitate to one based on, your experience and your skill set. Ansible, for instance, is very much script-oriented. So if you've got a traditional IT ops background, and you're used to scripting languages, you're probably going to like Ansible a little bit better. It's based off of Python and uses YAML files, and it's just pretty declarative in how it does things. Whereas Puppet, they have their own DSL that's based off of Ruby, and everything is kind of object-oriented in Puppet. So if you have a stronger development background, you're probably going to like Puppet a little bit better because it's more closely resembles the programming that you've done as a developer.
Okay.
Go ahead.
Go ahead.
I was going to say I think the one big difference between those two, though, is Puppet uses a centralized server. And you install a Puppet agent on every device that it manages, and that agent checks in every 30 minutes to ask, hey, what's my configuration supposed to be? And if the configuration currently on that device isn't what the Puppet server says that it's going to be, it's going to change itself automatically to match that configuration. Ansible, on the other hand, is a run once type thing. So you run the Ansible script on it and it configures it, and Ansible never bothers to check again. They may have a new product out that addresses that. Red Hat bought Ansible a few years back, so that may be something that they've changed recently. But the last time I used it, that was how it operated. And so that's a big difference between the two. In addition to the language that they use, it's that Puppet continually reinforces that configuration, whereas Ansible only does it when you tell it to.
Okay, so that's interesting. So to me, if I had, let's say I was in whatever, vertical industry finance or whatever, and I had a bunch of servers for whatever reason I needed to manage, it seems to me that maybe I might use Puppet to get everything up and running, get all the I don't know, software installed on all the servers. And the thing that I like about it is to me, it sounds like it has a centralized, server that all of the clients are checking into. And then if for whatever reason that, an administrator says, hey, looks like we have a security patch we need to push out to 400 servers, they can just update that in the Puppet server. And then, correct me if I'm wrong, but it sounds like at that point, those 400 servers, whenever they check in within whatever time frame, say, hey, I don't have this thing installed. I need to go run whatever script and I need to go get this installed. And then that kind of will propagate throughout the entire data center. Is that right?
Yeah, that's exactly right. Yeah, and the approach for doing that for Ansible is Ansible has an inventory list. So from your workstation, you would tell Ansible to just go do this against the inventory list. And so Ansible would go out to every server and do the same thing. It's just it's a push method, whereas Puppet's a pull method.
Oh, okay. So they both can kind of do the same thing.
Yeah.
Now, for, I'm thinking back to Chef. So Chef I could kind of use Chef or Terraform kind of use to build out, here's what my network layer might look like or whatever, kind of that architecture, that lower architecture. And then the actual applications and servers of what's on them, if it's going to be CentOS or if it's going to be something else, could be managed by Puppet. Is that correct? Will it install or help set up the operating systems like Puppet?
So sort of yes and no. A lot of times what I've done in the past is have a base image that I use. Especially because so much of my experience has been in AWS, I'll pull a specific AWS instance that already has the operating system on it.
Yeah.
And you can do the same thing with a bare metal type environment. If you're doing it on bare metal, you've got to do it a little bit differently because you've got to get something on there that's a bootloader that tells it where to go look for that. But yeah, you can definitely do that.
Yeah, the image makes sense because you're probably already going to know, hey, this is my go-to, Unix distribution that distro I want to use, so I'm going to kind of roll with that and then kind of stack these things on top of it, and then Puppet can kind of install that stuff, right?
Yeah, exactly. Yeah, because you'll most people will have their Linux distribution and they'll just stick with that. Although one of the things that Ansible does really well. I want to say Puppet does. Yeah, Puppet does it as well. Both of them are pretty much operating system agnostic. So if you tell it to install, the Apache web server on a server, well, on a CentOS server, that's yum install HTTPD. On Debian, though, it's apt-get Apache 2, and Ansible and Puppet, neither one, you don't have to tell them that the commands are different. When it checks in, it'll say, this is this operating system, and it knows which command to run based on that specific server.
Oh, so that's very useful. I mean, that reminds me of developing in Rails, where I just say, hey, I need a database table with X, Y, and Z in it. And one instance I might be using MySQL, and in another application I might be using Postgres, which if you've ever worked with both of them, they both have, kind of vastly different syntaxes. And I don't even worry about it when I'm at a higher abstraction level up in Rails. So it sounds like it's definitely performing that level of abstraction for you to make it a lot easier, which is awesome.
Yeah, definitely.
So the So it sounds like to me, and again, just recapping so I understand this, is that you can use Ansible or Puppet together with Chef or Terraform. And would you say that most of the time they are used together in unison, or do some companies just only use one, or kind of depends on the situation?
It really depends on the situation. I used Chef years and years ago, um, and I just picked it because I did some research and it looked like the way to go. That was pretty much the basis of that decision. After
Yeah.
learning more about it, I went to Puppet after that, and then went to Ansible after that. I've only played with Terraform just a little bit, but I think to get back to your question, I think it really depends on the environment. If you have a really large environment, you're probably going to have all of those. You're probably going to have, Chef and or Terraform for managing your infrastructure, and then use Puppet or Ansible or SaltStack for actual configuration management of the servers. The environments that I've been in, I've generally not used Terraform or Chef for those things because, like building a VPC for I work a lot with startups, and so for them,
Yeah.
we build the VPC, set it up, and it's kind of a done deal after that. We
Mhm.
don't really, there's not a lot of regulation or compliance requirements there, and there just hasn't been a need to manage or change that. I will use, which is maybe a good segue here, I'll use a Cloudformation template to set up that VPC for that environment. So there is some documentation on what the VPC is supposed to look like and how it was originally configured.
So yeah, that is a good segue. Like, so what AWS CloudFormation is a product by AWS. It's basically runs on their platform for only their platform. That's my understanding.
Mm-hmm.
So what exactly is it? Why would I want to use it?
So CloudFormation is it's essentially just a YAML file that defines the AWS services and resources that you want to use, and I've used it quite a bit. So what it ends up looking like is you'll have a VPC, for instance, and so you'll define that I want a VPC resource, and I want it across 3 availability zones, and I want a public subnet and a private net in each availability zone, and each of those has a NAT gateway for outbound internet access. And so you just define all of that in the CloudFormation template, and there's variables that you can use in the CloudFormation template, so that whenever one thing defined elsewhere in the template needs to be referenced, you can just reference it by a variable name. And so you take that template and then you just give it to the CloudFormation tool in AWS, and it runs off and does its thing and builds whatever it is you've specified in there.
So I could tell that, I'm not an AWS expert by any stretch of the imagination. And one of the reasons why this conversation came up was because I've been doing a lot of work on the side, just as like kind of a playground experiment, building a serverless application, with Postgres and on AWS using RDS. Then I'm using Lambda functions and S3 and SES. So given I have basically built my entire application in AWS, from what I'm understanding is I could potentially define this all in a YAML file and say, here's how this application is built. Now, that doesn't include the code, though, does it, to run the Lambda functions or something like that, or to create the database tables or anything, or would it?
I don't think so. I think it's just if it does exist, it's something I've never used. It's mainly just for configuration. So your specific application, you could have one, and I would definitely recommend using CloudFormation for the product that you're talking about. I would stay away from Ansible or Puppet, although both of those have plugins that build those resources. It just seems like a lot of overkill for what you're trying to do. So I would break it down into probably 2, maybe 3 YAML files for your environment. One that defines like your core infrastructure. So you've got your Postgres database, your SES topics. I would put that in one configuration file, and then another would contain your API gateway information on what it looks like, and then we talked offline. We talked about using the AWS SAM templates for building that.
Yeah.
That's where I would put my application code. In the SAM template, it might actually build your API gateway for you as well, so you wouldn't need to put that in CloudFormation.
Yeah, I actually used one SAM template. It was an existing one that had a lower level C library that I needed to reference. It had some bindings to Node, and so I built on top of that SAM application, whatever it is, to build my Lambda function. So that did work out pretty well.
Yeah, and then that's all in. It's all in code, right? So you can check it into source control and then so now CloudFormation, building it out through CloudFormation, it has a drift feature as well. Because the thing that I hate about AWS, actually I can't say I hate, that's a strong word. The thing that can cause you problems in AWS is you can log into the AWS console and point and click your way to success, right? You can get anything working just using a mouse and giving it some names and some text boxes, right?
Yeah.
Where that comes back to hurt you is later when you need to reference what you did, or especially as your team grows, if someone else needs to know how it was built, using the GUI in AWS, there's usually very little documentation or tracking on that. Or a worst case scenario, someone comes along and they make what they think is a beneficial change that actually breaks something. If that's not well communicated, you can spend a lot of time troubleshooting because something was changed and nobody knew it. So that's where the CloudFormation drift comes in. If you build your resources with CloudFormation, when you log back into the console, there'll be a drift detection button for that CloudFormation template, and it'll go out and it'll scan everything that it built using that template, and then come back and tell you if everything is still configured that way or not.
Oh, interesting. So it's almost like an automated diff on AWS's side.
Yeah, exactly.
Because I ran into that exact problem. I was building out, I had multiple Lambda functions, RDS, like all the services I mentioned already. And then I started thinking, I'm like, all right, and it's all in my head. And then what I actually wanted to do was talk to you about something. And so I started documenting it in a swim lane diagram. And then I started realizing, I'm like, wow, this is actually a lot more complicated than I anticipated. I mean, it's not a super complicated application. It's actually pretty easy. But there's a lot of different moving parts. And with AWS, you kind of just it's very a la carte. You get to pick and choose, I want this thing, and I want that thing, and I want this thing. And they all kind of just connect together. And I did it all point and click, except for a few times when I got into a couple of hairy situations of something not being configured properly. I had to make some notes and do it through the command line and cross my fingers and all that kind of stuff to hope it worked. But no, it worked out pretty well. Now, how does all this, I hear I can build, machines, I can manage, probably security patches, I can handle different types of compliance and monitoring, the stuff like that. With CloudFormation, I can do a whole bunch of stuff. And then we kind of get down to the lower level where it's just sitting on my computer, and I'm using something like Docker to build out, a complex environment that has queues and databases and APIs and clients on it that might have 7, 8 different containers running, so I can develop in a similar environment. Does this relate to any of those? Can I use that knowledge and move it into Puppet, or do they work with it, or is it just completely separate?
No, you can. And I've actually wandered away from Puppet and Ansible after going deeper into Docker. For the last 3 or 4 years, I think everything I've done, or not everything, but a huge percentage of the work I've done has just been using Docker. And so, Puppet and Ansible aren't really the best tools for that. They're really good if you're using something like Kubernetes or the Docker host environment. It can build those servers for you, but managing the containers itself is not really its strong point. If you're using something like Kubernetes, it's got that built into it, so it knows what the running environment should look like, and it will maintain it. Docker, I think it's Docker Swarm, has the same thing. And then the tool I've worked with a lot of AWS Fargate, very similar. It knows what the Docker containers, it knows how many there's supposed to be, it knows who's allowed to talk to who, and it just maintains that for you. So it sort of provides, those three tools sort of provide the same thing at a container level that Chef and Ansible, or Puppet and Ansible, would provide at a server level.
So it seems like Chef, Puppet, those ones there are something that you should consider if you have an on-prem solution. An on-prem meaning on-premises, that you have a wide number of servers that you have to manage, or a sysadmin or DevOps person has to manage themselves. Is that right?
Yeah, either on-prem or in AWS if you run a lot of EC2 instances.
But if you're running in like in a Docker environment, then kind of you could rely on the Docker tools like Swarm or Fargate or Kubernetes.
Right, yep.
Okay, man, that's a ton of info.
Cool.
But it actually makes sense now. Now I don't feel as uninformed as I did before. I'll give myself a pass on that. I had a much more colorful word for it, but we'll leave it at that.
You feel a little less guilty for not using one of those? You're like, oh my God, I should be using one of these.
Yeah,
I don't know why, but I should be.
And the same thing is back in we'll talk 10 years ago, I started hearing, Puppet and Chef and Ansible, and those three mainly being thrown around all the time in different work environments that I was at. And I always felt like, wow, I don't know what this is. I'd look up Puppet and I'd be like, okay, I'd manage a server. I'd look up Ansible, and I had to work with Ansible for a little bit. I'm like, I kind of get it a little bit. And then I had to use it at a client, and a really good DevOps, developer had built out the scripts for everything. And I just I figured out how it worked only through reading the code. It's kind of like if you're a developer, you can read C code, but a lot of them can't write C code.
Right.
It was kind of like one of those things.
Yeah.
And, but yeah, now I feel like I can kind of like wrap my head around like, all right, now I understand there's different categories. There's the setup of the actual infrastructure. There's then the actual server configuration and management. And then there's, the development and containerization stuff, which is kind of three different buckets really. And it really depends on where you're hosting it and how you're hosting it. Kind of depends on what tool you want.
Yeah, the further that you move towards a serverless type environment, the less interaction you'll have with those types of tools.
So here's a good question for you. Let's say there's a startup that's coming out. They're deciding what they want to do. Would you, at this point in time, it's going to be maybe a web app, it's going to have an API, databases, of course, they might have queues, whatever. And their options are open at this point. Would you recommend that they use something like Chef and Puppet, or would you recommend that they move into a Docker environment or into Cloudformation? What would be your recommendation for someone who's watching and wondering what to do, or where to spend their time?
Yeah, if it were like early stage startup, like the founder and or a developer, if those two aren't the exact same person,
like 0 to 5 people.
Yeah, I would push them towards something like Heroku at first.
Okay. What if you're going bigger?
What's that?
Sorry, I didn't mean to interrupt you. So if you're go ahead.
Yeah, no, I was just going to push them to Heroku because it's just the setup is super easy. They've got all the CI/CD stuff built in for you automatically, and especially for that size startup, it just allows you to focus on building your product, and getting it out there as fast as humanly possible to see if it's what the market's looking for. Don't spend any time building anything that you're not going to hand off to a customer at that stage.
Now, what if I know a lot of people are going to say, but Heroku's so expensive, or one of these other, passes or platform as a services are so expensive. I know it's cheaper if I just use these other services. What's your response to that?
Yeah, it's definitely cheaper if you go with AWS. My reasoning for going with that though is you can always move to AWS once you have people handing you cash. But if you delay someone handing you cash, you're putting everything at risk for something that may not happen. So what I recommend people do is start with something like Heroku. Once you have paying customers and you're starting to get a feel for the difference between what you're selling and what the customers think they're buying, because that's always the gap in startups, is you built this thing because you think customers want this. The customers told you what they wanted, this thing over here, and then the truth is somewhere in the middle. So once you start drilling into that and you've got revenue coming in, then it's super easy to migrate over to something like AWS using ECS Fargate, because it's a Docker-based solution as well. So you just move your Docker containers from running on Heroku over to Fargate, and there you'll have to do a little bit of infrastructure work as well. But now you're running on Fargate, so the cost is much, much cheaper, and the scalability is there for you.
Okay. Is there like a rule of thumb that you kind of say, like, hey, if you're approaching $1,000 a month on your Heroku bill, or is it 5,000? Is it 10,000? Is it 20, 30,000? Is there a certain rule of thumb that you're kind of like, hey, here's to the point where I think we might want to start looking at evaluating moving?
I think it's in the thousands of dollars per month. You can probably knock your Heroku bill, or you can probably run for about half the cost on Fargate that you can on Heroku.
Okay.
But you've got to make sure that spending the time and effort to move is the best use of your resources. So if you're in that startup phase and you're like trying to push out the feature that your customers have been begging you for, or moving to Fargate, I would focus on the features and keep working on the revenue, because it's just so important in that early stage startup to get that revenue engine up and spinning. And it may not be the most efficient way to go financially, but if you get that flywheel spinning fast enough, then you can always go over and do the other things. But when you're first getting that flywheel spinning, everything you do that's not continuing to spin that flywheel leaves it at the risk of slowing down.
Yeah, it's a good plan there. I know that you and I have worked with startups before that were on Heroku that had moved over to AWS, so we've definitely seen that. And I'm in the same boat. I recommend folks that they go with Heroku first, get everything working. And I personally use Heroku for my apps mainly, and this is, I'm not paid to say any of this, but it's easy. It is more expensive, but I don't even use the Docker version. I'm running a Rails app. I just git push, and it runs my migrations for Rails. I use Postgres. If I need a bigger instance, it's easy for me to upgrade. If I need Redis, I can just add on a Redis instance, and boom, it's there. It gives me the URL, and then I'm off to the races. And for me, at a smaller company level, it's worth it, because then I don't have to worry about having someone on hand at all time to manage this. I can just really rely on the infrastructure that Heroku has. And if for some reason I need to scale up, I might just need to scale up the dynos and incur a little bit of extra cost that month for whatever, maybe a big PR push or something came out.
Yeah, and in that case, the scale up is typically tied to an increase in revenue as well.
Yeah.
So it's not like it's coming out of your pocket directly.
Yeah,
it's impacting your profit margin, but at the same time, it's still more money.
Exactly. Well, cool, man. I think that wraps up for the questions that I have. I mean, you did a fantastic job breaking it down. I appreciate you taking the time to do that.
Yeah, thanks for humoring me and letting me do this live.
No, it's great. Yeah, this was fun. Thank you for having me on.
Right on, man. My pleasure. We'll talk to you soon.
Thanks.
All right, see ya.